I think fewer. I'm not sure I could work 1,700 into this one, but
She's so funny.
how many equations in motion?
Okay. 1, 2, 3, 6, 7, 8.
Is there one for each pair?
I love it. 1, 2, 3.
Or a column?
Not one for each pair, there's gonna be one for each object of interest.
7, 8, 9, 10. Oh, 10. 10? It's either 7 or 10. Or 6.
Alright, so how are you counting this up?
Okay, so, mass 4 has one equation.
Okay, so I got one from that.
And then rope 4 has one equation.
No, we're not gonna do an equation for the rope.
Oh, right.
Ropes are masses, so it's,
So then there's 2 for mass 3, 2 for mass 1, 1 for mass 2, and that's it.
okay.
1, 2, 5, 6.
Yeah, it's gonna sound a lot like I'm gonna contradict myself. We do need one for this.
Okay.
We're not doing one for the individual rope, but the connection point. I probably should change the picture where there's a ring or something like that in the middle.
Yeah. I know, I got it.
So, one for mass 4? No,
Yes,
one?
one for mass 4, and one for mass 2, and then 2 for everything else.
Okay.
So 1, 2, 3, 4, 5, 6, 7, 8.
Seven.
I counted it right?
Wait, where is the 8th one?
1, 2, 3, 4, 5, 6, 7, 8.
Why is there only 2 in the rope one? Oh, yeah.
I got 2 here and 2 there.
Oh, yeah, I got it. Sorry. Dumb question.
Alright, we need to, what is the acceleration?
Wait, what?
What is the acceleration? We just did the force diagram. Okay, so we have some freedom here to pick our coordinate system.
Yes.
So for mass 4, I got one equation, I only need to pick a positive or negative. Okay?
For the whole thing?
Up is positive every single time. Left is positive for. Do we need to do that? Like, is that super necessary for us to like choose a coordinate system for each of them, or can we say for this entire problem?
In this particular case, choosing one for all of it works.
Okay.
Is that what you want to
That's
do?
what I did yesterday, yeah. Yeah.
So we have opposite positive.
Yeah. And then the left is positive for our I hat. Wait, no, I'm sorry. I get my lefts and rights confused all the time. I meant right. I do that every single time. I swear. Right is.
Are you left-handed or right-handed?
I'm left-handed, so.
Same.
Yeah, so just, sometimes it just gets to me that my dominant hand is not the same as everybody else's.
Yeah. Okay. My memory trick was I write with my right hand. So that's how I know, but I guess that doesn't work for you.
Okay, so how, just. Yeah, let's carry on.
All right, 8 equations of motion. I'll have 1 for 4, 2 for, 1 for 2, and 2 for the other 3 things. Yes,
Do we need to do all the equations of motion?
yes. Well, you thinking about taking shortcuts, combining some stuff?
Well, I don't understand how doing everything, like all of this. Well, all this is fine. I know how
That's what I'm saying, I'm so
but like
proud.
how I mean, I'll probably see, but like how like doing like M4 help us figure out what the tension of rope 3 is.
Because what's happening in M4 affects M3. What happens in M3 will affect M1. What happens in M1 is going to affect this. So that's how it all ties together.
So if theoretically like M4 was just a box of chips
8 equations of motion here. We've got 9 people. Someone's gonna get left out, but let's get a different voice for each one.
Mass 4.
FT4 minus weight 4 is equal to mass times acceleration 0. How do you know that we're talking about like mass 4? Is that like I don't have to put like JCat 4 or
Well, I mean, the big clue that it's mass 4 is the fact that these two forces are acting on it. But we can do, so J hat 4. And then we'll have J hat 2, and then I hat 1, J hat 1, I hat 3, J hat 3, and then J hat connection point, I hat connection point.
Would you take points off if we don't, like, if this isn't our final answer, but like we don't do subscripts, we don't write specifically kilograms in our equation, as long as it's not the answer?
You don't have to write units in until the answer, so you can get away with that part. Subscripts, if you don't write subscripts, but in the end you get the right answer, then I will assume you kept track of it in your head and just didn't write them down. I would still, if you got the right answer in the end, I would still give you credit for it.
So I always forget to write like that.
But if you don't write the subscripts and there's a mistake somewhere, then I will look at your paper over my glasses, maybe title a little bit. All right, one down. Ava's done hers. Next.
okay, J hat 2 is
And you don't have to do them in order, but, okay, but J hat 2?
tension minus weight 2. Tension 2 minus weight 2.
What tension?
Tension 2
Okay, minus weight 2.
equals mass times acceleration, which is 0.
Acceleration is 0 for all of it?
It's all, the whole thing is in static equilibrium.
For now or for the entire problem?
For the entire problem. I think in the original problem, I had a couple extra parts to it that I dropped since then. And in one of the parts, I think M3 was moving in dynamic equilibrium. And I think also originally mass 4, I then had a part where mass 4 was actually swinging in a circle.
That sounds awful.
You know, step by step. All right, next voice. I can do the random picking, that should be fun. Abby.
Let's do mass 3. Alright, I have mass 3.
You know, I hat 3?
Yeah.
Okay.
Would it be no, I meant J hat 3, not I hat 3. J hat 3.
But you want to do J hat 3?
Yeah, instead.
Okay.
It'd be FT4.
Wait. You doing horizontal or vertical?
Horizontal. My bad.
You're doing I hat.
Yeah.
You're doing,
Sorry,
okay,
yeah.
I hat 3. So FT4?
Yeah. Would be minus W3.
All right. When you're doing the equations of motion, pick a direction.
Okay.
And you're only doing forces that
Okay.
are in those directions.
Okay.
So if we're doing horizontal,
You would have to pick something.
then those are the two
Yeah.
forces. If you're doing
Okay.
vertical, those are the two forces.
Okay.
So which one are we doing?
Horizontal.
Horizontal.
Yeah.
Okay. The next step is think about the positive direction here.
Okay.
Positive direction is to the right. All right,
So
go.
it'll be plus. Cause it's to the right, would it be plus?
Yep.
Okay. So FT4 plus. Nope, that's the going opposite way.
Plus FT4.
Yeah. F3 plus FT4.
So, oh, we're doing I, there we go. F3,
Plus FT4.
which way is FT4 going?
Then it'll be minus.
Yeah,
You're just
minus.
doing plus. Minus FT4 equals. Would it be M3? 0 equals 0.
Yep.
Trying to think.
We have
Is that a
volunteer.
P or a D on a J hat C something?
Okay.
That's
I knew it
CP
was
for
negative, but she said
connection
plus,
point.
I was like, this is plus. Yeah.
All right. Volunteer? Was that a volunteer gesture you just made, Erica?
No, I was just
Okay.
telling her good job.
Tatum. Well, we'll just go with the other name that I was touching, Ash.
I could do J hat 3.
Okay?
That, is weight 3 minus, or normal, force 3 minus weight 3 equals mass times 0.
Technically, mass 3 times 0, but ultimately, it's gonna be equal to 0, so it doesn't matter. All right. I guess some of you are playing the game of you're gonna be the one who doesn't get called. Oh, volunteer? Yes.
For I hat 1.
Yes.
FT1 minus F1 equals, well, in this case just 0, but it's M sub 1 times 0.
You lost one of your horizontal.
F3, is that involved?
Yeah. Minus
Right,
F3.
minus F3.
Yeah, there are two forces acting to the left.
I thought, sorry, I was involving that in the mass 3 one.
Well, it's involved in both.
You good? You good?
All right, next. Helps if I actually look at the paper. Stephanie.
For J hat 1,
Yep.
sorry, I had a bad time. I got, normal force 1 minus the normal force on the 3. Minus weight equals M times 0.
Which way?
Wait, mass is subscriptive. Can you put a subscript? 1.
Yeah, we're doing one. So that's one, that's one.
I'm trying.
Okay, yeah, I mean, it's all part of the learning process. All right, 2 more to go, 3 people who haven't spoken yet. Oh, wait, are we? That's right, so we have Talon, Erica, and Tatiana. So, Erica.
Okay. The connection point, that's a hard one. Okay, I'll do the J direction, so.
Okay.
Do I pick the R route?
You pick the,
The R1, 2, and 3? Is that a connection point?
The connection point's right there, that red dot.
Okay,
And so you got FT1 going to the left, FT2 going down, and FT3 going that way.
Oh, jeez.
yeah, okay.
We did skip a step earlier,
Yeah.
which makes this one slightly more difficult.
Can we do that step?
Yeah, what did we skip?
Decomposition.
Yes.
Decompose, whatever. it
Yeah.
is.
Since our coordinate system is horizontal and vertical, we have one force that is not horizontal and not vertical, so we have to break that up. So, I guess that's the only one left there, so.
So it's just J divided by I?
So I have FT1 going that way, FT2 going this way, FT3 going that way. And ultimately, the question is, what is the magnitude and direction of this? So I'm just going to create an angle here, theta. So what am I breaking up?
53.
Okay, and how does that break up?
So it goes up FT3 sine theta. And then right FT3 cosine theta.
Okay. Now, you're on, Erica.
Okay, FT2 plus FT3 sine theta,
FT2
or minus FT2,
minus FT2.
no, FT2
Minus the next thing.
FT3 sine theta.
All right, in this particular case, it will work because we have acceleration of 0.
Okay,
But from a process point of view, up was positive, down was negative. So that,
let's have that.
you would still get the same answer in the end. So I'm just gonna flip that around for you.
Let me do it right here. So FT3 sine theta minus FT2 equals, oh, there's no mass, so 0,
And FT2.
yes.
One equation to go, and Alan?
Okay, so FT3 cosine theta minus FT1 equals 0.
All right, so we have our equations of motion. What's next?
Substitution.
All right, so where do we have formulas?
So it would be, starting with J4, it would be FT4 equals.
We don't need the diagram anymore. All right, so FT4,
FT4 equals weight 4, which equals mass 4 times little g.
all right,
And then, J hat 2 is FT2 equals, M2 times little g, and then I hat 1 is FT1 equals friction 3 plus friction 1. Without the question mark. J1 is normal 1 equals normal 3 plus mass 1 times little g. And then I hat 3 is friction 3 equals tension 4. And then J hat 3 is normal 3 equals M3G. And then the J hat, whatever, is tension 3 sine theta equals tension 2. And the last one is tension 3 cosine theta equals tension 1. from there, we start substituting even more and more.
And then the solving, there is one more substitution that we'll need to make. We can get to it as we go. I mean, the process that I go through works great, especially if you can see where you can get away with not doing a substitution. But sometimes you just plug in numbers. I know M4, it's 2 kilograms. Yes,
I just have
The
a-
last equation, what is that?
that's FT3 cosine theta equals FT1
You tried his best.
in pure gibberish.
I just have a
Okay,
question.
That's what happens when they're always hating on the tall people.
You're tall?
I would prefer the boards raised.
So for F1, for friction 1, on the third equation, would that be equal to 0.8 times normal 1, like normal force now?
Yes,
Okay.
so that's the other substitution.
I just didn't, I wasn't looking at the paper exactly, so I didn't know the number.
F3, you would not do that substitution because I didn't give you a coefficient.
Ft1 equals F3 minus F1 is equals Ft3 cosine theta?
Wait, say that again?
Did I write this wrong?
Are you on that last equation still?
Well, I'm noticing that the third equation, Ft1 equals F3 minus F1.
That equals F3 plus F1.
Oh. Well, it still equals Ft1,
Yes,
and the last one equals Ft1.
yes,
So they're the same thing?
yes.
Okay.
Why don't we replace F3?
We'll find F3 based upon this equation right here, because that's equal to the tension in 4, which is equal to N4G. Also, I didn't give you a coefficient of friction there, so it's, if I did a mu S3 times Y3,